Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to use Lagrange multiplier to minimize this function f, x squared plus y squared, subject to the constraint 3x plus y equals to 10. Now, you know, to minimize a function, we need to find critical numbers, and in order to do that, we have to compute the partial derivatives. Okay? But we have a constraint here that we have to consider as well. So instead of finding critical numbers of f, we'll find the critical number of a new function. We'll define a new function using this Lagrange multiplier. So first, let's take this constraint that we have and rewrite it and form a function expression from it. So we rewrite as 3x plus y negative 10 is equal to 0. And then we call this expression as a new function. So it's like a function is equal to 0. And this function, call it g. So g of xy is 3x plus y minus 10. All right, now we define a new function. Let's call it big F, and this function will be on x, y, and the Lagrange multiplier lambda. And the definition is this is equal to the function small f minus lambda times the function g. Okay. Now let's write down the expression for f and for g, and we will have our function, the new function, the big F. So f is x squared plus y squared minus lambda times g is 3x plus y minus 10. Okay, let's simplify it and expand the second term. So we get negative 3 lambda x, negative lambda y, and positive 10 lambda. So this is the expression for our new function. Okay. So in the next step, we compute the partial derivatives, the first partial derivatives of f, so that we can figure out the critical numbers. All right. So let's compute fx. So this is the partial with respect to x of this expression. Okay. So let's go term by term. Remember, partial with respect to x means the other two variables, y and lambda, they are constant. Okay. So the first term is x squared and its derivative is 2x. Second term is y squared, it's a constant, derivative is 0. Third term, it has an x, so negative 3 lambda is a constant and derivative of x is 1. And notice the next two terms, no x, so derivative will be 0 as well. So this is our fx. Okay. Next, compute fy. Same way again, first term has x, not y, and therefore it's a constant, so the derivative is 0. Second term, derivative of y squared is 2y. Third, no y, derivative is 0. Fourth is negative lambda times 1, and then constant again for the last term, derivative is 0. Finally, compute f lambda. So now x and y, they are both constant. Okay, so x squared is a constant, 0, y squared, 0. This one has lambda, and the constant is negative 3x. Okay, fourth term also has lambda, constant is negative y. And then last term, constant is plus 10. Okay, so we have all three partial derivatives. And to compute critical number, we have to set each one equal to 0 and then solve for x, y. Okay, so let's set each one equal to 0. So we have three equations, three unknowns we should be able to solve. Okay, so let's see what's the easiest way of doing this. I will take Fy first. So let's take 2y minus lambda equals 0, and then right away we have lambda is equal to 2y. Okay. Then plug that lambda value in the first equation. So now take 2x minus 3 lambda is 0. So 2x is equal to 3 lambda, and plug in lambda equals 2y. So 2x is equal to 3 times 2y. And you can cancel out the 2, so you get x is equal to 3y. Now notice the last equation doesn't have any lambda, only x and y. So you can plug in the x value here, and then we can solve for y from there, right? So let's take this last equation now. Negative 3x, negative y plus 10 is 0. Okay. So we have negative 3 times x is 3y, negative y plus 10, 0. So this is negative 9y and negative y, which is negative 10y plus 10 is 0. So you can take the negative 10y on the other side. So we get 10y is equal to 10. Divide by 10 both sides. We get y equal to 1. So we got one value, one of the variables. Now since y is 1, you come back up here and you plug in 1 and you get x. So x is equal to 3 times 1, which means that x is 3. Now notice that we don't really need to calculate lambda, because we only want to minimize our function f, which is in the variable x and y only. So critical point of the function small f is 3, 1. So we got our critical point. Now we only have one critical point, right? And we have to minimize the function. So that point will give us a minimum function. We know that. If you want to test though, you can always use the second partial test to see whether this point will give you a minimum or not. So if you want, we can quickly do that. So let's see. The function f is x squared plus y squared. So notice our new function f has that x squared plus y squared as the first part. So if you ignore the lambda portion, we can't already see that the first partial derivative of small f will be right here, right? 2x, 2y. So we can easily compute fxx. So we just ignore the lambda portion. So fxx is going to be the derivative of 2x, so it's 2. Fyy, again you ignore the lambda, so the derivative of 2y with respect to y will be 2. And fxy, so you take 2x and take the partial with respect to y, and that will be 0. So you can easily compute these three. And then find d. d is fxx, fyy minus fxy square. So see, this will be 2 times 2 minus 0. So this is 4. Therefore, d is positive, and fxx is 2 is also positive. And you know, if d is positive and fxx is positive, that gives you a minimum. So this tells you that min at the critical number for the function f. So we have to minimize our function, and we found the critical point, and the minimum value of the function. So this is our critical point, and we can say that the minimum value is 3 square plus 1 square. So this is 9 plus 1 is 10. So we have the minimum value of the function, we have the critical point, and we have tested that that is a min, and that completes the problem. Thank you.